Today we're going to cover absolute value. Okay, absolute value is certainly not new to us. And yesterday we had an overview about the if statement, right? About the if statement. And we talk about that there are only two kinds of statement in mathematics. One is just a statement including descriptions of rules and or a statement about facts of in numbers. And the other kind of statement is if statement. If we look at the, if you look at the 6 mathematical principles, right? So let's look at the 6 mathematical principles. The 6 mathematical principles. The first and second, right? What is the first one? First one says any number times 1 stay the same. And second one says any number adds 0 stay the same, right? So any number times 1 stay the same. And the second one is that any number plus 0 stay the same. These are statements, right? These are the statements. You can use it anytime. You can use them anytime. So these are statements. And then number 3, number 4, number 5, number 6, they're all if statements. They're all under if statements, okay? These are if statements. So these are the principles for if statement. For if statements. So principle number 3, 4, 5, 6, these 4 principles are typically used for if statement. And the first two principles can be used for any statement, whether they're statement or if statement. You guys follow me? Because they are just truth. You can use them in the situation of if statement. You can also use them in the situation of just a general statement. But the 3, 4, 5, 6 in specifically, they are for if statements. Okay, so now if you take a second look of the mathematical principles, and you will see that, right? Because number 3 says if A is the same as B, right? Number 4 says if, right? They have an if statement. So those 4 principles until 5 and 6, they're about applying these principles to what situation. So if you have an if statement situation, you can apply 3, 4, 5, 6. And number 1, number 2 can apply to any situation, okay? So that's the connection between the two kinds of statement and the principles we can use, right? Now, next, today we're gonna focus on the absolute value function again. We have covered these earlier on in the semester. I believe is in the first 3 weeks we cover those. If you need to watch those, go back to watch them. And now we're going to recap on that. We mentioned that this function is absolutely important. No calculus professors who teaches calculus can go around this function. They will have to use this function somewhere in their first few chapters of instructions to make certain points in their calculus contents, right? And it's extensively used. So familiarity, understanding of this function is essential. So as we recap this, and what are the key in this, right? So we've done this before, and this is the second time we focus on this, and we're going to apply whatever we have learned to the if situation, to the if statement situation, right? So let's review. So what can you say about the domain and range of this function? One sentence, okay? You were being quizzed on before, and we talked about them in classes before. We did a graph. So I would appreciate some contribution if you would like to share that with us. Domain range. pictures, right? Picture is something we're very familiar with. Okay, very familiar. What does that picture tell us, right? We went over the function extensively in the earlier chapters. Our focus is understanding. So what can you say about it? Any comments? You can put it on chat. You can also speak up. Domain and range. This is not a test. You can go back to look at your notes. No comments? Okay, so I'm going to put it there. The absolute value of any number is at least 0. The absolute value of any number is at least 0. So mathematically, we will write absolute value of any number, x represent any number, for any real number x. This is true. Okay, it's reflected on domain. The domain, okay, if you look at that box, right? If you look at that box, the domain with the horizontal span. So domain tells us that the x can be any real number on the number line. The range, of course, it goes in both directions indefinitely. It can go to negative infinity, it can go to positive infinity, and the output, the smallest output is 0. It can go as high as possible. That's the output, horizontal, vertical, right? It can go as high as possible. Okay, so that's a domain range in one sentence. So you plug in any number here, you always gonna get a number larger than 0 or equal to 0. Okay, so this is how we express mathematically. And by words, okay, we say the absolute value of any real number is at least 0. Okay. Sometimes, last time I was addressing this, I at the end of it, Farouz mentioned that I may like to address the definition. The definition of absolute value is the distance between number to the origin. Okay, the concept of the absolute value is the distance between a number and its origin. For example, if you look from a number line, if you look at this from the number line, right? That's the number line. Oh, maybe I should change the color. It's a little too striking. It's too striking. Okay, so that's the number line. Okay, make it green. That's the number line, right? We have origin. This is the origin, right? And the distance between any number to the origin. For example, I have a number here or a number there, the distance. So you just have to count how many units in between, right? So and we don't care about the direction. So the distance between, okay. Oh wait, I just deleted. Oh gosh, let me do it again. Okay, the number line, okay, 0, the point of reference, right? Any number you pick, okay? And we look at the we look at the distance between a number to origin. For example, the distance between -2 to 0, right? Suppose we have a -2 here. Suppose this star is -2. Okay, suppose this point is -2. From -2 to 0, how many units are there? There's 2 units. So the absolute value of -2 is 2. There are 2 units. Okay. We do not care about the direction. We just care about how far away between these 2 places. And from -2 to 0, there are 2 units. The distance is 2. And in another scenario, say this number is say 1.8, right? This star at this point is 1.8, for example, 1.8. So the absolute value between 1.8 and 0 is a positive number. So there's a absolute value of 1.8 is going to be 1.8. We've done similar things before, right? And later we look at absolute value as a function, right? Because you have input and output, and we realize any real number can be the input. Okay, so the other perspective we had, okay, another perspective okay, we see this as input, and then we take absolute value, you know, using the same concept, which measures the distance between the number and the origin. Okay, so we produce this output. And the output, of course, is absolute value of x. And we know that absolute value of any number is always at least 0. Positive number, negative number, or 0, right? So that's the situation we had discussed before. So from the function perspective, we did the graph, right? And we made lots of observations. So this is the recap. And we know that the absolute value of any real number is 0 or positive, right? You have all these different ways of saying it. Now, the question is, do we really understand it? Do we really understand this statement? I tell you the truth. From my observation, some people understand it, some people don't. They can say it, but they don't necessarily understand it. So today's practice is going to focus on helping us, because number one, you need to identify whether you do understand it or not. How do we know if you do understand it or not? By using some, we're going to use some examples to see how you respond, right? People telling us that I understand, but I just didn't do it right. Well, if you didn't do it right, that means you didn't understand it completely. You guys follow me? So number one thing we need to identify, do we really understand it? Sometimes we have to be willing to understand or willing to know we may not understand it as much as we should be, or as much as we wished for. Okay, so now this is a recap about domain and range. So next I'm going to clean this up, right? That's a definition. And next, we did a graph, right? If you guys want to see how the graph is done, you can go back to watch the other lectures. But at the time, we have 3 important sentences we went over and over again. Okay, so we summarize with that context, the absolute value of a positive number is what? It's the same as the number. Okay, and the absolute value of 0 is the same as 0, right? And the absolute value of a negative number is its opposite. Okay, remember we did that? And these three sentences summarized, we put these two sentences together, right? We put these two sentences together. So it's a positive number or zero. Positive number or zero, we call it non-negative. Non-negative number. So these two sentences are combined. The next one is the absolute value of a negative number is its opposite. So if we write it using algebraic notation to translate, if we use algebraic notation to translate, right, what do we get? The absolute value of a non-negative number. How do we express that? Well, if we use the number as x, and here we need to specify that x is going to be what? Greater than or equals to 0. That's how we specify it's a non-negative number, right? So the absolute value of x when x is non-negative, greater than or equal to 0, is the same as the number. The same as the number now is x. Right? And the absolute value of a negative number, how do we express a negative number? We'll put x, right? And next, we're going to explain that x is negative. X itself is negative. So the absolute value of x when x is negative is its opposite. How do we express its opposite? The opposite of x is negative x. Okay, how do we further translation? Further translation from these two sentences. Okay, further translation to these sentences. The absolute value of x when x is greater than or equal to 0. Okay, the absolute value of x, we use this notation, the absolute value of x, shorthand notation. When x is greater than or equal to 0, it is positive. It's the same as x. The absolute value of x is expressed using this notation, absolute value of x. When x is negative, is its opposite. You guys see that that shorthand notation step by step. So last but not least, okay, these two pieces. Okay, so we're going to put it down this way, equal, because is equal, right? Is equal. And we combine these two, it becomes, this will be the formal form you're going to see at the entry of calculus. At your entry to calculus. The absolute value of a non-negative number. Okay, so we put that over here. It's the same as x. And here we're going to have a if. Okay. The next one, x is less than 0. And we put an if. Right? So the absolute value of a negative number is its opposite. So this is the form you're going to see very often. And there are lots of variations about it, okay? I hope I'm thinking I will go over the variations about this before I take my leave. But today, right, you can see the step-by-step translation. So this is the alternative expression, which you're going to use a lot. And its variations you're going to use a lot in the first 3 chapters, most likely in your calculus class. And you'll continue to use it in calculus 2. You continue to use it in calculus 2. Okay, but So that's the review of what we have done in the previous week, in the previous weeks, okay, in the first probably 3 weeks of the semester, right? Is that enough review? Do you guys have any questions? Do you guys have any questions? Yeah? No? Okay. With that said and done, I want you guys to look at the basic 456. Basic 456. Yesterday, during our overview, we talked about these 3 types, right? They are all in the category of if statement. If statements. What does that mean? Right? There are if statements. In the category of if statements, they're all if statements, okay, about the function absolute value of x. X, we don't know what it is, but it tells us we want the output, we want the output is given, the output is 3. We want to find the input. The output we want to be less than 3, and we want to find the inputs. The output is we want it to be larger than 3, and we want to find the input. So the nature of the question is similar. We want to find inputs, okay? In the past, I believe you guys probably have learned these, right? Because most of my students, when I taught pre-calculus, tell me if I need to explain, okay? When I taught pre-calculus, when I address these 3 situations, the student will be able to draw these graphs properly. Okay, they will be able to draw these graphs properly. That's no problem. But what I want to introduce is under the function concept. Under the function concept, okay, for equal to 3, okay, where we would be to identify points. Both points we identify, and this broken line we draw here is y equals to 3. Okay, it's equals to 3. That y equals 3 line. Okay, so that's y equals to 3 line. That's horizontal line, right? So we have it there. We have it there. That's y equals to 3 line. For the condition given that we know the output is 3, then we have 2 inputs, -3 and +3, such that these 2 points, when input is -3, the output is going to be 3, because the absolute value of -3 is +3. And the other point is input is 3, output is 3. Do you guys follow me? So these are all the solutions we have. These are all the solutions we have. These category is called equation. These are called inequalities. Okay, yesterday we talked about in our overview that equation inequalities, they are all in the same category of if statements. If statements. Okay. Less than 3, however, okay, for less than 3 is that we want to identify all the input such that the outputs are less than 3. So what are those numbers? And we recognize those numbers are between -3 to +3. Okay, all of those numbers, okay? How many are there? Infinite. So including -2.99, -2.7, -1.6, 1.2, 2.999, 2.999999999, you know, as many as you wish, but they are between -3 and +3 without including -3 itself, without including +3 itself. Okay, so this is the new perspective I want you guys to see in the function perspective, right? And you can see the output, right? The output, you have 2 output pieces, right? Which these curve the output, right? How high it is. There, you know, this piece is positive. This piece is positive, right? And that there's a 0 there. There's a 0 there. And this piece is positive. right? That is just telling us the output are always positive or zero, absolute value, right? In the larger than 3 case, we know the output, the input that will make the output larger than 3, it would be, there's still a lot of numbers, right? But they will be outside, say, negative 3.0000005, for example, right? Negative 4, negative 5, all the way to negative infinity. So there are infinite number of solutions. And the next one is the other piece we have that will make that statement, make the output larger than 3, that will be 3.1, 3.2, 3.5, 3. Whatever, 4, 5, and so on and so forth, point in between. Infinite number of solutions. Does everybody follow me? Okay, with that said and done, a lot of our students who have done this, they can also show me, they can also show us the interval solution, okay, which is very, very nice. Okay, the student will show us the interval solution. For this case, the solution would be, you know, it's just x equals to negative 3 or positive 3. Okay, no problem. Hold on. Or positive 3. For the other case, the student will usually be pretty good with negative 3, positive 3. They can give us that interval properly. Okay. And the next case, the student typically will give us the answer negative infinity to negative 3. Or, and some people even use union, right? I will use or and union, the same thing, right? Or 3 to infinity. If you are here, if you understand these solutions, you're pretty good. That means you understand what you're doing. But what's interesting about it is that what's most useful for you is actually the inequality. It's the inequality. But this is the place a lot of our students get stuck. A lot of our students in calculus class, they cannot manage these inequalities well. And as a result, they will lose points here and there, and they lose points a lot. Okay, so for that reason, I said I would tell you that it's great that you know these, but that's not enough. You have to know their inequality relatives, the inequality relatives. Okay, so these forms, no problem. Either one is fine. Either one is fine. And on these two, okay, on these two, you need to be able to do this for and, because this is read as, okay, so I'm going to give you the reading, okay, the reading. We need to understand meanings, right? We need to understand meaning. So how do we read it? How do we read it? Okay, in this case, you would say solution to that set inequality here. Okay, the solution to that would be all real numbers. All real numbers greater than let me use separate because this I don't like the blinking. I don't like the blinking. It just drives me crazy. Oh, I'm sorry. What's going on? Okay, so let's focus on how we read this. How we read this. Okay, if you have any questions, please don't hesitate to interrupt me. Okay. So now, how do we read this? how do we read this, right? A lot of our students have hardship with these. Okay, but these inequality form of solution are most important to you in order to carry out the remaining algebraic operation, okay? It reads, okay, all real numbers between -3 and the +3 exclusively, meaning that -3 and +3 are not included, okay? Another way of reading, okay, all real numbers such that all real number x, okay, so let me use x, such that, okay, all real number x such that x is larger than, is greater than -3 and smaller than +3. Okay, the key word here is and. Remember truth table? Remember the introduction to truth table? Why did I introduce it then? It's here is because of this. Okay, I want you guys to write it down and to really think about it. Okay, make sure it's sink in your mind. Okay, so it's x is greater than -3 and smaller than 3. So the key word is and. Now, so let's look at the other one. What does this mean? That's the solution for absolute value larger than 3, right? So this is for absolute value larger than 3. You know the graph, you understand all of that. That's great. Okay, but on this part, the solution, this piece of solution, I should put that over here as well. Okay. Wait. Okay. The solution, this reads, so when you're reading this, you need to be conscientious about the truth table. The truth table. If you understand the difference between and or, and this is the time to apply it. This is time to apply it. Okay. So for the next one, the solution reads as all real numbers, all real number x, okay, or any real number x, all real number x, okay, such that x is less than -3 or greater than or greater than, oh, come on, or greater than 3. The key word here is or. Do you guys follow me? So you have to be mindful. You have to be mindful about what you're reading. When you're reading and, everything you know about it, the truth table and should come to your mind. When you're reading the or, everything about or, that truth table should come to your mind. Do you guys follow me? Do you guys still remember what truth tables are? Do we still remember that truth table? So that's the meaning. That's how you read it. Do we need to review that truth table, you guys?
I say yes, Professor.
Okay, let's review the truth table. Review truth table. We have two statements. A, B. A and B. A and B. Right? We have truth table. One truth table is about A and B. The other one is about A or B. Remember that at the time we talked about the registration of cars. Okay, this is and or mean the same thing in the legal world. In the legal world, for example, if the check is written to you and your mother, then both of you need to endorse that check before it can be cashed, right? But if the check is written to you or your brother, one of you can cash the checks. Does that make sense, you guys? So these and or are the same meaning in the legal world as well. Okay, so now if I say now, so if yes is true, no is false, right? Suppose this is true and this is true. So true and true, A means one statement, B means another statement. So when we put two true statements together, what happens? True and true is going to be what? True. If one statement is true and the other statement is false, and you put true and false together, that's going to make it what? The entire A and B will be false. If one is false, the other one is true. False and true is going to be false. One is false, the other one is false. False and false makes false. Do you guys follow me? Okay, these are the principles, and or they're also implemented in computers, in the computer hardware, software, everywhere, technology. In all the technology, these truth tables are applied, okay, embedded, designed into. You guys know those chips, right? Those chips, they have to comply with these principles, and or, and so on and so forth. Now, the or case, right? One statement, another statement. If one statement is true, the other statement is true. True or true is what? True. True or false is true, because it's or, right? In the case that the check is written to you or your brother, right? Only one of you need to sign it, and you get a cash, right? You can cash the check. So false or true will also be true. And of course, false or false is false. That's the truth table I refers to. So now when we go back to see, that x must be greater than -3 and smaller than 3, it's and, so both must be true. Greater than -3 and smaller than 3, both must be true at the same time. Only in the and case we can write the inequality like a choo-choo train. Do you guys follow me? And the inequality sign has to face the same direction. when you write it this way. You cannot say, oh, one face the one direction, the other one face the other direction, okay? You cannot do that. Only when you have an and situation, you can write it this way, and the inequality sign face the same direction. You guys follow me? All right. Now, for the or case, we cannot combine these two. We cannot combine these two. In other words, whenever you combine them, it meant and. When you combine them, meant and. For example, a typical mistake, okay, extremely popular mistake. I use uppercase to emphasize how popular they are. Extremely popular. I saw these mistakes all the time, okay? Some students would like to write it this way. They will say -3, right? Because they just combine them. They like this choo-choo train kind of form. So they will say, okay, x is less than -3. So they will write it less than -3. Right? That's x and less than -3. And they will also greater than 3. They will write it this way. You cannot write it this way. You guys follow me? If it's in or relationship. When I was in graduate school, I was a TA. When I went to graduate school at USC, and I was a TA. At that time, I saw these mistakes. The professors I was TA for, they complain about this mistake all the time. They say, oh, why students do this? They do that. We see that every year, every semester, every course. Okay, when I start teaching, guess what? I see it every semester, every year, every course. Okay, for this reason, this is exactly the reason I introduced truth table. I decided to introduce truth table in all the algebra classes I teach. Okay, so now let's read that again. When you have an or situation, they cannot be combined because whenever you combine them, they become and. For example, in this case, when you combine it, it becomes and. What it means, right? How when your professor read this, how would your professor read it? Your professor will not read it as you intended if this is what you intended. Your professor will read it as the solution is any real number x such that, okay, x is larger than 3 and smaller than -3. I want you guys to read this sentence. Because whenever you do this, that's how your professor read this. Okay, I want you guys to read this and you tell yourself what it means. Okay, give me a second, okay? Farouz, can you chime in just for 2 minutes? I'm just going to go to the
Yes, Professor,
okay?
yes.
Okay, how about you lead them to read this sentence, right? To read this. And you come back and tell me, what does that mean?
Okay.
It's a terrible mistake. We have seen this for ages. I'll be right back.
Okay. Anybody has suggestion? Anybody? Let's see. So, yes, let me read the chat. So Christopher, it would mean X is somehow negative, but also higher than a positive at the same time. Okay, that is somehow it's good, right? Good answer. Thank you for sharing your idea in the chat, Christopher. Good job. Any other suggestion? And while we are waiting for Professor come back, let's feel comfortable and chit chat, unmute and bring it up your ideas in that regard, because as you see, it is very, very common mistake, as Professor says. So why we could not put those inequalities into one inequality and becomes mistake, typical popular mistake. It is. So in reinforce, or explain a little bit more regarding Christopher's suggestion, we can use the number line. We can use number line and just try to graph it. How can X be less than -3? Where is the less than -3 on the number line? Any suggestion? Less than -3. Okay, Professor, you're back.
Thank you.
You're welcome.
So how was our discussion? So when you read out aloud, right? Some people will say, hey, this is what I meant. This is what I meant. No matter what you meant, this when in the language of mathematics, that's not going to be read the way you wish for, because you want to get points from your professors, not the other way around. You need to understand in mathematical language, this means the solution are numbers that's larger than +3 and smaller than -3. Does such a number even exist? Tell me, can you give me a number that's larger than 3 and smaller than -3? Does such a number exist? That's why I'm asking you to read it. Read what it means. Does such a number exist? In this world, there's a number that's larger than 3 and at the same time less than -3. It doesn't exist. But why do we keep seeing these mistakes? Okay. In my assessment, I believe every math professor have seen this mistake, but we see this so often. And I've been frustrated about how to correct this, right? As I said earlier, how do I correct this mistake? It's just, we see this every semester, every class. Okay, so you need to understand the grammar. You need to understand the grammar, how it's being read, right? Does everybody get it? Can you promise me you're never going to make that kind of mistake? Or you promise yourself, I'll be gone soon, right? Can you promise yourself you're not going to make that mistake? Because once you make that mistake, you get zero for it. Do you follow me? So that's why math has to make sense to us. It has to make sense to you first, but you have to follow the grammar of mathematics. As I said earlier, you can only do this if it's in and relationship. What is that and relationship? What is that and relationship? Where did we come from? It was this picture. Between, there's a boundary. There's a boundary. It's bounded by -3, and it's bounded by -3 from the bottom, and bounded by +3 from the top. You guys see that? And on this one, these two intervals, right? One is larger than 3, these two intervals are disjoint. They have no connection. They are separated. You guys get it? They are separated. They cannot be combined. Do you guys follow me? They cannot be combined. They have to be connected only by or. Do you get it? I want you to understand this is the reason why I introduced truth table at the beginning of the semester for exactly the same reason. Okay, in fact, I introduced truth tables for all the algebra classes I teach. It's very important you get that logic, okay? So whenever you combine them, it will be read the way in mathematics how it's being read. So I don't want to see this mistake. I don't want to see you guys make this mistake. Okay, did I get my message across? Could I hear some response?
Yeah, I understand it.
You not only need to understand it, you have to be able to do it and express it correctly. Okay? Very good. Understanding the first step. Okay? So never ever make this kind of mistake. If I see this mistake, I usually would write next to the mistake. I said, does such number even exist? But I'm not sure if the students still get it. That such a number does not exist. You have to think about the answer you get. You have to think about the answer you get. You guys get it? That's why we focus so much on meaning. Right? Absolutely. You know, so now I hope we can move forward, right? Now, all the absolute value questions, all the absolute value, you know, inequalities, equations, and the key to solve them, they're all here. They're all here, okay? Number 1, number 2, number 3, and the tables that are examples we have here. So next, I don't think these kind of questions should be new to any one of you. You have seen them before. So what I like to do is that I'm going to see your work. I'm going to see your work. So if you look at the notes number on basic 4, 5, 6, it should be on page number 6. I would like you guys to arbitrarily, you choose the question, okay? You guys are going to choose the question. Do you guys have any questions? Okay, so what I like you guys to do, so at this point, I want you guys to choose to choose questions of yourself. Okay, you're going to choose 2 questions out of basics 4, 5, 6. Choose 2 questions arbitrarily, okay? And you start working on them. I'm not going to choose them for you, okay? But I would suggest you choose the question that seems hard for you. It seems hard for you, or seems to be, you're not sure about the answers, okay? And I'm going to give you 10 minutes. Okay? And I'll have the breakout rooms ready for you. If you want to join with Farouz, or you want to stay with me, and feel free to ask me questions. I want to see your work, okay? I want to see your work. So I'm not going to force you, but I'm going to invite your work. So turn in your work either by pronto or upload on chat. Okay, if you prefer to be anonymous, no problem. I will not review, don't write your name on the work you turn in. Okay, so for the next 10 minutes, you're gonna choose 2 questions out of basic 4, 5, 6 and work on them on your paper pencil. So after you're done, you pick a picture and you send it up to me. Okay, shall we do that? Let's go. So I'm opening the room. I want you guys to work on these, okay? If these questions are completely new to you, I would be happy to explain. You just need to let me know, okay? But I kind of assume that you guys have been exposed to these kind of questions before. Okay, you guys have been exposed to these kind of questions before. Okay, absolutely important that you get over this. Absolutely for your success in calculus, calculus 1, calculus 2, and so on and so forth. So let's see if we can make the best shot. Okay, so let's get started. 10 minutes. Don't be shy. I'm here to help you, okay, to eradicate mistakes. They look simple, but they could command a lot of points. They look simple, but they could command a lot of points. Chat or pronto. We want to see your answers in inequality form, okay? Answers in inequality form. think, okay? Think about what you get, the meaning. It has to make sense first to you. You have to understand that's the grammar in mathematics. If that makes sense to you, professor, who's going to give you points or taking points away? How are you doing? Anybody ready to submit your work? Any questions? Any questions for me? How's it going? I'm closing. All right, we got some submissions. Wonderful. All right. Okay, we got another submission. Okay, so let's look at the first one. All right, let's look at the first submission here. Okay, thank you for submitting. Number 10, our basic 5. Very good job. Okay, and the next one, less than -8 or x larger than 8. Very good job. Okay, good job here. All right, so let's look at the other one. The next submission. It looks like next submission. Okay, the next submission is right here. Greater than equals to 5, less than equals to 5, or greater than equals to 5. Very good. Excellent. Okay, I'm glad to see this. Larger than 4, less than -4, or greater than 4. Perfect. Very good job. The picture drawn are good and always good. All right, so I have reason to believe that most of you guys got it, right? Okay, wonderful. Thank you for your practice, your contribution. And are there any more submissions? All right, so I'm not, then let's move forward, okay? Next. You guys have chosen questions to do. That's very good. But now I'm going to give you some more questions. Okay. On basic 1, I'm sorry, basic 4. How about number 5 and 6? On basic 5. How about 10, 11, 12, 13, 14? 10, 11, 12, 13. And basic 6. On basic 6. Basic 5, 11, 12, no, sorry. Make it 11, 12, 13, 14, okay? Same thing for basic 6. Could you guys work on these questions? You can also submit your answers. Okay, I'm going to open the room. I'm opening the room. Please work on these questions. There are 10 of them. 10 of them. Give me 2 minutes. I'll be right back. Good job, you guys. All right, how's it going? Five, six, right? Basic 4, 5, and 6. We have an absolute value of x equals to -3. That's number 5. Number 6. The absolute value of x equals to 0. Right? 12, 11, 12, 13, 14. All right, I'm gonna get you guys back. Come back. Is everybody back? Almost, almost. All right, guys, welcome back. Was that enough time? I see that Farouz is drawing pictures, right?
Yes.
Farouz is drawing pictures. I'm sorry I had to interrupt because I want to make sure we finish these by the end of the class.
That's fine, Professor. Thank you for giving us chance.
Of course, my pleasure, because I want to identify what issues we have in this area. Okay, so number 5, what are the solutions? What is the solution?
Number 5, there is no solution.
Perfect. Why there's no solution?
It has to be a positive number, I believe. Or no?
What is that powerful reason you can give me? What is that powerful reason you can give us? Right, we reviewed so much about absolute value function, right? Your answer is correct, but what's the reason? You want to have a powerful reason for it, right?
Yeah.
What is that powerful reason?
The absolute value of a non-negative number is the same as the number.
Can you write it down for yourself? Does that convince you? Do you know X is non-negative or not? Do you know the sign of X? You don't, do you? No solution is correct, but the answer, the reason is not powerful enough. What is that reason? This is the reason. Okay, we got a message from, okay. I'm looking at this reason. Okay, I see this submission, but I'll get to it, Christopher, just a little later, okay? The first one is right, the second one is not. Okay. What is that powerful reason? Where did I put it? Wait. Do you guys see the screen? That powerful reason is saying the absolute value of any number is greater than equal to 0. What is any means? So no matter what you put there, the absolute value is going to be greater than equal to 0. It will never be -3. Are you guys with me? Do you guys follow me? What does it mean? What the word any means?
All real numbers.
Right? Do you guys follow me? This is the singular powerful reason you need to carve on your forehead so everybody reminds you. Do you follow me? The reasons you said earlier, they're not to the point, because I can find holes in it. Okay, I can find loopholes in your statement. You guys follow me? I can find loopholes in your statement. If you're a lawyer, you're probably not going to win the case. Okay, so what will be the most powerful reason? That this is the most powerful reason. This is why this is going to be tested. This is going to be tested on your midterm exam. Domain range in one sentence. Do you guys follow me? You know it, but you don't use it. If you don't use it, what's the use of learning it? Okay, if you want to use this in a mathematical term. If you want to use this in mathematical term, you can also say for any real number x, right? The absolute value of that number is always going to be greater than or equal to 0. And 0 will never equal to -3. If you want to put in mathematical term like that, you certainly can do that, because 0 will never ever be equals to -3. So now let's just see what the use of the graph. What the use of graph? What's the use of graph? What is the use of this graph? Another perspective, right? I saw Farouz was drawing the picture, right? So what does this mean? This means that I want to find the inputs. I don't know what the inputs are, but I want the output to be -3. Okay, I want the output to be -3. So I have the picture of absolute value of x, right? And I want that output to be -3. So I'm going to draw horizontal line, -3, red. This is y equals to -3. -3 has no touch to the curve. That means there's what? That tells you what? No solution. It tells you, if you go back to see the definitional function, it says there's no input such that the output is -3. Do you guys follow me? Do you guys follow me? These are the language, this is the language of mathematics. Because there's no touch, there's no input outputs, right? So for that output, you cannot find input. That means there's no solution, right? Because we're looking for the input such that the output is -3. Do you guys follow me?
Professor,
So yes?
if you look at -3 as the output also, then it might help us. -3 is the output.
Yeah, the output, -3 is the output, right? There's no input will guarantee you have a -3 output, is that right? So all of these things we put together, they're all consistent, but they give you different perspective, give you reason. The one singular most powerful statement is right here. All of these exercise, okay, I just give you for basic 4, I give you 2 exercise. For number 5 and 6, I give you 8 total. All of these can be resolved by using this one sentence. This one sentence is that powerful. You guys follow me? So now let's look at number 6. What is the solution? What is the solution?
Isn't it just x equals 0?
Exactly. Perfect. That's a perfect answer. Because if you would draw the same horizontal line, you're going to touch the curve at one place. And that one place is one point, give you the input, and the output is 0. So from every perspective, you need to think about these different perspectives, guys. You must be doing that. Otherwise, it's very difficult to make it through the courses. All right? Very good. Does everybody understand that? X equals 0 is the only solution. It's the only solution. Do you guys follow me? Okay, you can see it from this perspective, right? From that perspective, what would this be? What would be the line here? The line would be what? Would be 0, right? It crosses at one place. And that one point that 1 point tells you the input, when the input is 0, the output is 0. Okay, so from every perspective, you need to understand this is one singular, most powerful statement. Okay, you need to really digest every single word, Now, with that understood? Right, this guy here. I'm going to put this powerful statement here. So what is the answer for number 11? The negative number, the opposite value of negative number, it's opposite. It's opposite. But then you put a positive in the parentheses. What does that supposed to mean? Okay, I see 2 comments. I'll get back to you. Okay, I'll get back to you on that. Just remind me. So let's look at number 11. We all agree with that, right? We all agree with that, right? So what is the solution to number 11? What is the solution to number 11? Is it ever impossible? Is it ever possible? Is this going to happen ever? You take absolute value of any number, are you going to ever get a negative? Because less than 0 means negative, right? So what will be your answer to number 11?
No solution.
No solution, that's right. No solution. Why? That's the powerful statement. That's the reason. The next one. What's the solution to less than or equal to 0? Less than 0 is impossible. Can it be equal to 0? Right? So this sign means what? Less than or equal, or means or in truth table. Right? So you have 2 cases. Right? This implies less than 0 or equal to 0. This is impossible. This is possible. So what is the solution? What is the solution? Are you guys there? Or refer to that truth table. Refer to truth table.
We got the chat response, Professor.
Wonderful. 0, very good. Very good job. The only solution would be x equal to 0. Okay, how about number 13 and 14? Yeah, how about 13? How about solution to number 13 and 14?
Professor, can we say question is invalid question?
No, the question is valid. The question is valid. There's nothing wrong with the question.
Number 13, the absolute value of any.
Okay, I see an answer from Alexa. Yes, absolutely. For both, that powerful statement will solve all of our questions. Do you guys see that? Do you agree? That statement is how powerful it is. And that statement is in the picture itself. It's in the picture itself, isn't it? Look, take a second look at that picture. Take a second look at that picture. Input, output. Right? This statement tells you the output for absolute value of anything is going to be at least 0. So less than 0 is not going to happen. But you can ask that question, right? The question itself is no problem. It's just there's no reason, there's no input to make it happen. And that's how we say there's no solution. Do you guys follow me? So let's look at basic 6. Right? The same powerful statement here works. Now you tell me, what is the solution to number 11? What's the solution to number 12? What's the solution to number 13? And what's the solution to number 14? Put on your thinking cap. Number 11, x is greater than 0 or x is equal to 0. Solution to number 11 is x is greater than 0 or x is equal to 0. So you mean x is negative cannot be solution?
Yes. All real numbers.
What do you mean all real number? All real number for what?
Negative and positive.
So negative and positive. But you
Yeah.
here you say x is greater than 0 or x is equal to 0. So what is the solution? You need to give all the solutions. Right? You need to give all the solutions. So here you're saying the solution would be x greater than 0 or x is equal to 0. That can be written in mathematical term. You're telling the reader that x is greater than or equal to 0. That's what you're telling the reader. You're telling the reader these numbers are solutions. You're telling the reader the opposite are not solutions, i.e. negative numbers are not solutions. Are you sure about that answer? Suppose we're arguing in a court. We're arguing in a court. That's right, you got it. In this case, this statement, this powerful statement is staring at our face. Staring at our face, telling us what? The solution is all real numbers. You got it, Alexa. Okay, so the solution is what? Solution is all real numbers because every number you take absolute value of it, it's going to be at least 0. Do you guys understand what I'm saying here? Okay, I hope I don't see this mistake. This one, I don't know how many partial credit you get. You're not going to get many points. Okay, so that's at the most. Okay, this answer at most depends on your professor. Okay, some professors are lenient, some people are not, right? If you have in kind of professor like as mean as I am, you probably get a 0. Because this shows lack of understanding of absolute value. All right. I hope that's clear. Okay, so that's the solution. Okay. Number 12. Number 12. Number 12.
The solution is all real numbers except 0.
Perfect. 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 All real numbers except 0. Wonderful. All real numbers except 0. Wonderful. But how do you, there's an alternative way you can write it. The alternative way would be x not equal to 0. That's it. So either you write by words, you write by this form, because this means the same thing. Okay, this means, you see, understanding the meaning in mathematics is absolutely essential. I cannot move on a single minute if I don't. If I don't know what I'm talking about, you can tell right away. Yeah? All right, 13, 14. 13, 14. Oh, we're past. So I'm going to take a few more minutes of your time. 13, 14. What are the solutions?
There are no solutions to number 13.
No solutions? Are you
Oh.
kidding me?
Oh, it's all.
Yeah.
The absolute value of any x is greater than -3, because all absolute values are.
The absolute value of any real number is going to be larger than or equal to 0. And
Right.
0 is larger
So it's
than
all real
-3
numbers.
always. So the solution is what? All real numbers. Okay. Isn't this sentence powerful? If you understand it. If you understand it. Follow me? Okay. So that's all for today's lecture. I'm going to get to the comments by Hazel and George. Your comments, Hazel's comment says absolute value of a negative number is its opposite. Just remove the positive. How about that? I know you get it. The absolute value of a negative number is going to be positive. Okay, but you don't need to add that positive. Okay. The absolute, and George's, the absolute value of a negative number is its opposite. Remove the positive. Because you have already guaranteed the result is positive. Okay. Because when you put that positive there, number one, is it redundant? Right? Number two, is it redundant? Does that make sense to you? Can you show the graph for 11, basic 5? Can you show the graph for 11? 11, basic 5. The graph for basic, for 11, basic 5. For basic 5. That's the absolute value of x. Less than 0. If I show the graph for less than 0, right? Less than 0, how do you show less than 0? There's no graph in the negative part, right? The entire graph if you look at the entire graph, this piece is a positive, this piece is a positive. You just have 1 point that's a 0. You don't have any negative piece, so there's no solution. Is that clear? Is that good enough, Hazel? You get that? Right, so no piece of the graph is in the negative side. This is the negative side. You guys see this negative side, nothing. You have a 0, you have positive. Do you see that? That's how you see the graph. So let me see, there's other comments. Did I miss any other comments? I think I get them all. Any other questions? Right, you see, to truly understand the absolute value, this sentence, okay, I'm gonna put lots of love to this sentence. Do you agree with me? This sentence is super powerful. Yeah? Do you agree with me? Yeah? Great. Okay. Last but not least, we have a submission. I want to have a closure. Okay, Christopher submitted a piece of work, and I appreciate that. I'm going to get to it. Let's see. Where's my? They're calling me to go to their meetings. Pronto. Did you submit it to Pronto, Christopher? I thought I saw it, but I don't see it now. Chris? Wait, let me check my phone. I think I saw that because it showed on my it's on my phone, but it doesn't. The second one you wrote there, it should be less than -8. You wrote less than 1 on your submission. I see it on my cell phone, but I don't see it here. Oh, there. I'm sorry. My bad. My bad. Okay. So this is the submission by one of you. All right. So let me correct it. This is good. This piece is good. Okay. The second piece, basic 6, you have less than the absolute value of x greater than 8. You have your picture correctly, but this should be -8. Okay, this should be -8. I don't know why you write +1. It should be -8. You see that, Chris?
Yeah.
All right. I thought that might be just a careless mistake. Okay. So that's all for today. I will see you guys tomorrow. I'm sorry. Sometimes I'm pretty dramatic in my voice, and I hope I don't shock you. But I just want to get your attention, okay, to think a little deeper. Anyway, and I'll see you guys tomorrow.
Thank you very
Thank
much,
you.
Professor.
Thank you, Garuz. Great
You're
job.
welcome.
Okay, keep
Our
leading me.
professor, thank you for the lesson.
Oh, sure. My great pleasure. Okay.
See you tomorrow.
Have a good day.
Of course. Thank you so much. I'll see you guys tomorrow.
Thanks for the lecture, Professor.
Of course, anytime. My great pleasure.